How is malware created? What Windows internals are utilized when developing malware? Welcome back to Suit Up and Hack, and in this video we're going to start developing malware so that we can gain an understanding of it from inside and out. Previous videos we've taken a look at the reversing of JavaScript droppers. How is it actually put onto the computer? Well, I've always wanted to take a look by building it and then reversing it. So sit back and enjoy, and we'll see you on the other side.
As I mentioned in the intro, we're going to dive into the fundamental concept that's in both malware analysis and ethical hacking, and that's shellcode injection. We've got this C code right here that when run, it's going to pop Windows Calculator. It just doesn't call calc.exe though, the normal way. Instead, it performs a series of steps to load and execute raw machine code directly from memory. Understanding this technique is crucial because it's the foundation for how many malicious programs hide their true intention. So let's break it down step by step. First, you see here this variable shellcode. Well, that is just a big block of hexadecimal numbers. This is the actual shellcode. Think of the shellcode as the raw native language of the computer's processor. Just pure machine instructions. It got its name shellcode because traditionally you'd be trying to open command.exe or bin/shell on a target machine, but in this case the shellcode is really just calc.exe, popping calc.exe as we say it. So here is the actual shellcode injection process that we're going to go step by step, and then I'm going to hit start without debugging in order to grab that or pop that calc.exe. So when you first get into this program, it always opens right there with main in C code. The program needs to find a place in its own memory to store that shellcode. It can't just throw it anywhere. For this, it actually uses Windows API VirtualAlloc. VirtualAlloc is basically asking the operating system, please reserve a chunk of memory for me. We're looking for something of this size, and here's the permissions. We're initially going to be setting the permissions to page read write, which means we can read from and write to this memory block. However, it's important to note that we cannot execute this code, and that's because of a security feature. This is something that had come up in the Windows API design process. Alright, so once we get back, this base has basically the pointer to this allocated memory. Well, now we have to give that empty memory space our shellcode. And that's what this API or this function call does right here. This is taking it, it's basically a simple memory copy operation that copies our machine code instructions for calc.exe into the memory region we just allocated with base, shellcode, and shellcode size. So where is our memory? What do we want to copy in? How much do we want to copy in? Now you remember earlier where we talked about that security feature just a few seconds ago, or about a minute ago, where we talked about it was page read write, not execute. Well, we now have to change that because right now it's marked as simply read write. If we tried to run code from it, processor and OS would throw an error and crash the program because this is something known as data execution prevention, or DEP. To get around this, we use VirtualProtect to change the permissions. We're going to initially just set this old protection to 0, and then we call VirtualProtect to pointing at the memory, how much of the size, what do we want to take it to. And so basically we're saying that piece of memory I allocated, I want you to mark it as page execute read, which makes the memory region executable. And this is basically a technique of allocating that memory as executable so that we can write the payload and then change it to read execute in order to evade the detection. Now finally, with our shellcode in place, our memory marked as executable, we just have to run it. This program does it by creating a new thread and telling it to start executing at the beginning of our shellcode. A new thread will kick off, but instead of running a normal function, it starts reading and executing that raw machine code we placed in memory, which is our calc.exe. Then finally, we just have some cleanup here. So let's go ahead and run it. And hopefully we get to see that this thing, we had the shellcode injection, allocating, boom, we got memory here. Awesome. So why do we learn this? Well, it's because this exact pattern of allocate, copy, protect, and execute is at the heart of malware loaders, droppers, and packers. They use this method to unpack, run malicious code in memory without ever writing the final payload to disk, making it much, much more difficult for traditional antivirus software to detect it. Now you have a better understanding of how low-level injections work. You can better recognize them during reverse engineering, which is what we're going to do in our next video. We're going to take this executable and drop it into Binary Ninja, because we know what it looks like. We know what the source code looks like. Let's get a better idea of what the pseudo C, how it maps backwards, and we can continue our reverse engineering process. Make sure to check out next video, which should be on display right now, and we'll see you in the next one.